All right, guys, here's our first lesson on linear equations. So that's this whole unit. This is the first one, and we're going to talk about slope. So whenever I ask people what slope is, I tell them, just tell me in one word, what's slope? And the word I want you to use when describing slope, it's a ratio. We already know what a ratio is. A ratio compares two things. So what exactly then is slope? Well, it's a ratio because it compares two things. But what does it compare? It compares the change in y to the change in x. So the first thing I want you to understand is that rate of change. Rate of change is a ratio that compares how one variable changes to another. Okay? On a linear graph, which is what we're doing, that's what this unit is about, this is called the slope of the line, right? So, slope is written as a ratio of the vertical change, which is change in y. So this triangle is a delta, and it stands for change. That's a mathematical statement. So it's the change in y to the horizontal change, which is the change in x. Because the vertical change is the up and down, that's the y-axis, and the horizontal change is the x-axis. So it's always comparing change in y to change in x, always. This remains constant for any 2 points on the same line. Slope is written as a function, it's a fraction, not function, fraction in simplest form. So remember, you would never say slope is 6/3. You always have to simplify it to 2 or 2 over 1. I have to calibrate this real quick. Sorry, guys. And then we're going to talk about the types of slope. All right. So here's what I want you to do. Actually, on the left side of your paper, or no, this is two-sided, left and right side. So flip one paper over so you have a blank piece of notebook paper, right? When a page flips over, you've got that blank page. I'm going to tell you a story, and I want you to write it down, okay? All right, so here's the story. Write this down. We are going to say that all mathematicians ski left to right. So here's my skier. You'll see that? Here's my skier. And all he has are these poles. So let me get on this side. So he's got these poles, and he's going up this mountain. And all he does is have poles. So you see how steep this mountain is? He's climbing up this mountain, and he is puffing up this mountain. That's what he's doing. He is puffing up this mountain. He gets to the top of this mountain, and he sees this downhill. Okay? So he's at the top of the mountain, and he sees this downhill, and he's looking down, and he's like, oh my gosh, I have worked so hard. It is so nice. So he goes down this hill, and he's picking up speed, and then he's zooming straight across. He zooms straight across, but poor guy doesn't know that there's a cliff, and there's all these jagged rocks. So he's zooming over here, and then he dies. He's dead. In fact, he's so dead that his body parts are spread out everywhere. Completely dead. All right, now, so I didn't say it ended well. So when you look at this graph, or first of all, where did this story take place? He's a skier. Where did it take place? It took place on a mountain. So anytime we see the letter M in algebra worldwide, it is known that it is slope. So anytime you see the letter M in linear equations, M always stands for slope. Okay, so that's the first thing. That's what we're talking about, M equals slope. When you see the skier and he's going uphill, remember he skis left to right. So on a graph, when you see a line that goes up from left to right, I want you to think puff, puff. That skier's going puff, puff. It is a positive slope. Positive slope. When you see a line that he's going downhill, remember skis left to right, so when he's going downhill, he's saying to himself, this is nice. That means it's a negative slope. It's a negative slope. When you see a line where he's going straight across, I want you to remember that's where he is zooming. Z. That Z stands for 0. That is a 0 slope. And when you see a line on a graph that is where he's dead, he dies, it is undefined. Remember, it's undefined because his body parts are spread everywhere. So, that is kind of the story for slope. I'm going to X out of that and then bring up, hang on, sorry guys, I'm going to bring back up our notes. That's not it, hang on, coming back. All right, here we go. So the types of slope, which is just what my story was. This is a positive slope. Oh, and the variable for slope is m, which we talked about, took place on a mountain. We have a negative slope. A negative slope is where he skis left to right. He goes downhill, negative. We have a zoom, which is a zero slope. And we have a dead, which is an undefined slope. So those are the 4 types of slope that we have. When you look at number 1, I can tell right away. I'm just going to go through it real quickly and tell you right away if these are positive, negative, undefined, or 0. So number 1, positive. 2, negative. 3, zero slope. 4, undefined slope. 5, positive slope. 6, negative slope. Hopefully you're saying them with me. 7, positive slope. 8, negative slope. 9, negative slope. 10, negative slope. 11, undefined. 12, positive. 13, positive. 14, negative. 15, positive. 16, 0. So hopefully you can get the overall, whether it's positive, negative, 0, undefined. Now, we can also be more specific when we look at the slope. So not only do I know it's positive, but positive what? So here's what I want you to remember. Slope is change in y over change in x. This is a specific ratio. It has to be you are comparing the change in y over the change in x. A lot of times you'll hear people say it compares rise to run. And that's true because which axis do you rise on? This is my y-axis, this is my x-axis. So which axis do you rise on? You rise like an elevator up and down on the y, and you run straight across on the x. So if I look at that, rise over run is the same thing as change in y over change in x. It's the same comparison, just kind of different language. So it depends on what you're looking at. All right, so if we know that my skier skis left to right, and I want to find the slope of this line, I'm going to choose my leftmost point. So here's my graph, here's my leftmost point on that graph, and here's my rightmost point on that graph. I know it's comparing change in y to change in x. So how far am I going to rise from this leftmost point to this rightmost point? I'm going to rise, here's my y-axis, 1, 2, 3, 4, 5, 6, 7. 7 is my rise, so my change in y is 7. And what is my change in x? So my x, or my run, how far am I going to run? 1, 2, 3, 4. So my slope then is 7 over 4 because I changed 7 on the y, 4 on the x. And it's already simplified, so my slope is easy, 7 over 4. Let's take a look at number 2. Here's my leftmost point, here's my rightmost point. And I always go left to right because my skier skis left to right. So I'm going to read that graph left to right. So 1, I know it's negative. So he goes down how many times? 1, 2, 3. So negative 3 is my change in y. Over 1, 2, 3, 4, 5, 6, 7, 8, 9. So my change in x is 9. But am I going to keep it as negative 3 over 9? I'm not because it's not simplified. So I'm going to simplify it to negative 1 over 3. And I can just double check that because it's a constant rate of change. If I go down 1 over 3, that should stay on the same line. So let's just check. Down 1 over 3. Down 1 over 3. Down 1 over 3. So see how that remains on that line? So negative 1/3 is correct. All right. Now what I want you to do is I'm going to go through quickly the slope. So you can pause it and do it on your own and see if we get the same thing. So number 3 is 0. My slope is 0. Number 4, my slope is undefined. That's the symbol for undefined. Number 5 is going to go, my slope is up 1, 2, 3, 4, 5 over 3. My slope for number 6, my change in y is down 3 over 1, so it's negative 3 over 1. Number 7 is positive 4, 1, 2, 3, 4 over 2, but that reduces to 2 over 1, or just 2, that's okay. Number 8, my slope is down 4 to the right 4, so negative 4 over 4, which is just negative 1. Number 9 Number 9 is down 3 over 4. Number 10 is down 5 over 1. Number 11 is undefined. Number 12 is up 2 over 3. Number 13 is up 1 over 4. Number 14 is down 2 over 4, which reduces to negative 1/2. Okay, so if you have questions on those, email me or come and see me, and then tune into part 2 of homework 4.1.